Volumes of Revolution, the Washer Method Part 4. In this video, we're going to do some examples revolving the region shown around both horizontal and vertical axes. We're going to set up the volumes, but we're not going to solve them. Let's start by revolving this region about the x-axis. That is the line y equals 0. So if I go this way and draw some representative cross sections, first thing I notice, I have empty space, which means I have 2 radii, and that the width of each of these cross sections is dx. So everything will be x's. So my volume will be the bigger cross sections minus the smaller cross sections. And there are a few things missing here. I'm missing the length of my radii, but I'm also missing the limits. So let's find the limits. Now I could probably guess and check these limits. Like I know they intersect here at the origin, and I could guess and check this one. But what if I couldn't guess and check them easily? I, of course, could find the intersection points by setting the functions equal to each other. And then doing a little bit of algebra. I'll move it over here. Remember not to divide out things, but to move things over, then factor out. So I know that, indeed, it intersects at the origin. X equals 0. Easy to see that y equals 0 as well, because y equals 2x or y equals 1fx squared. And then up here at x equals 4, which means y equals 8. Since the width of my cross-section is dx, I will choose the x limits. So the integral from 0 to 4 of pi times my big radius squared. Radius length is big function, in this case big Y minus small y. I'm going to write it like that so that I don't forget to square the 2 and the 2x. My little radius over here, big Y minus small y. Again, I'll put these inside of parentheses. And that will give the volume if I revolve the region about the x-axis. Remember that we're going to set these up or we're not going to solve them. So what if I were to revolve this about the line y equals 8 now? Again, there's some empty space. So let me erase just a little bit of this and then redraw it for us. Because I really want to see my radii clearly if I can. And there will be 2 radii because there's some empty space up here. Big radius from the axis to the far side, little radius from the axis to the near side. And let's just go ahead and plug in down here because we're becoming experts at this. So the big radius squared, let's see, the big radius is big Y minus smaller y. Don't forget to square that. Don't forget times dx. That gives it a volume or a third dimension. Let's subtract off the smaller ones. Here's our little radius right here, big Y minus our small y. And we'll square that as well. So let's take that exact same region and let's revolve this around vertical lines. So recall that our region was formed by intersection points at 0, 0, and then 4, 8. If y was 2x, we can see that x equals 1/2 y. And then if y is 1/2 x squared, I would multiply by 2. I would get x squared equals 2y. And then x is the square root of 2y. Once again, we're going to set up these volumes, but we're not going to solve out the integral. And let's revolve this one around the line x equals 4 to start. Empty space means 2 radii. The volume will be big volumes. dy, because the width of a cross-section is dy, minus the smaller volumes. And now that everything is in terms of y, our limits should be in terms of y as well. So if we go about the line x equals 4, I'll write out the big radii and the little radius here. The big radius is right here, so it will be the larger x minus the smaller x. This part here is the end of an arrow. And then our little radius, right here, if you can see me drawing it, is the big X minus the smaller x. Which will give the volume setup as such. Pi times big radius squared dy minus integral pi times little radius squared dy. Now, I'm not going to do the work for you. I'm not going to show it. I'm just going to put an answer down. What if we were to revolve this about the y-axis, that is x equals 0? So if you'd like to, stop the video here, draw your picture, draw your radii. There will be 2 radii. And then when you come back, I will put down the integral for you that gives the volume. This one isn't too hard to work out, but I will leave the answer like this.